In this video, I will discuss the JEE Advanced PYQ from the topic Current Electricity. This question has appeared in the year 2021. The question is based on modified meter bridge and on Kirchhoff's current law and voltage law. Timestamps are given in the description box. You can watch parts of video if you're running short of time. This is the question. You can read it. In order to measure the internal resistance R1 of a cell of EMF E, a meter bridge of wire resistance R0 equal to 50 ohms, resistance R0 by 2, another cell of EMF E by 2, internal resistance R, and a galvanometer G are used in a circuit as shown in the figure. If the null point is found at L equal to 72 centimeter, then the value of R1 equal to dash ohms. We can pause and run this question. Let me call this point as point A, B, C, D, and this point as P, and this point as M. The resistance of the part of the wire A to P is proportional to the length. That is L, which is 72 centimeter, divided by the total length. Since the meter bridge, it's 100 centimeters. They have not given it, but you'll understand it as 100 centimeter, into the total distance R0, which is 50 ohms. So it's 72 by 2, 36 ohms. So the remaining resistance of 50, distance between the points P and B, it's 14 ohms. 36 plus 14 should give the total resistance 50 ohms. Since this point corresponds to null point, that means the current flowing here is 0. That is the meaning of null point. This point is adjusted such that the current in this bridge is 0. So there is only one current flowing in this circuit. Let me call it I. The same I flows here. Here the current is 0. The same I flows here, the same I flows here. So we can find this current in terms of this cell EMF. So the current is the cell EMF E, which is driving the current, divided by the total resistance of the path, which is R1 plus R0 by 2, plus this wire resistance, which is R0. So the total resistance is R1 plus half R0 and then 1 R0, so it's 1.5 R0, which is 50 ohms. So this value is 1.5 times 50, that is 75 ohms. R0 is 50, so 50 plus half of 50 is 25, 75. Applying KVL in this loop, A, P, M, D. We can write summation of drops equal to 0. So from A to P, the drop is the current into the resistance of this length A to P. Along the direction of current, in a resistor there is a voltage drop. So that is I into resistance of RAP, that is 36 ohms. And here the current is 0, so the drop in this R is 0 because the current is 0. But from here to here there is a drop of E by 2. So plus E by 2. And the drop from here to here is IR1. Along the direction of the current there is a drop, IR1. And here there is a rise, voltage rise. So it's minus E equal to 0. KVL is written in the form summation of voltage drops along the closed path is 0. So from A to B there is a voltage drop because along the direction of the current there is a drop in a resistor. Here the drop is 0 because the current is 0. And from this point to this point, there is a drop of E by 2. So plus E by 2. And from here to here, there is a drop of IR1 because along the direction of current, there is a drop. And here is a voltage rise. So we have to put minus E equal to 0. So I in terms of E is there. So if you put this thing, E will cancel throughout. So what you get is 36 by R1 plus 75. And these two we can combine as E by 2 plus E by 2. And E will cancel. So we'll have plus half. These two will combine as E by 2. And E will cancel throughout. And then IR1. It's minus E by 2. It's minus half. So R1 by R1 plus 75 equal to 0. IR1. So R1 divided by R1 plus 75. So this equation, there is only one unknown, R1, which you have to find out. So these two can be combined as 36 plus R1. Denominator is R1 plus 75 equal to so this is 0, so half can go on the right side. So cross multiply, this will become 72. When 75 goes to the right side, so remaining is 3 here. And then 2 times R1. And then 1 R1 goes here, so R1 equal to 3 ohms. This is a simple calculation. Cross multiply and simplify. 3 is the correct answer. This is what I explained here. Resistance from A to P is proportional to the length, which is 72 by the total length. It's a meter bridge, so the length is 100 centimeters of the total resistance R0, which is 50. So it's 36 ohms. So this remaining resistance from P to B is remaining of 50. So 50 minus 36 is 14. At null point, the current in this bridge is 0. So there is only one current in this outer loop. So that current we can find by the total EMF, which is driving the current, by the total resistance. R1 plus R0 by 2 plus from here to here R0. So 1.5 R0. So I in terms of E is known. Applying KVL in this loop, A, P, M, D in the form summation of drops equal to 0. Along the direction of current, there is a drop along the resistor. So from A to P, there is a drop because the direction of current is from A to P. So the drop is the current value I into the resistance, which is 36. And from here to here the current is 0, so the drop is 0. And there is a drop of E by 2 here, so plus E by 2. And here the current is flowing in this direction, so there is a drop of IR1. And here is a voltage rise. So in terms of drop, it will be minus E equal to 0. So this KVL in the form summation of drops equal to 0. So I in terms of E is there. So if you put that thing here and cancel the E, we'll get this one. And there is only one unknown here. Simple manipulation will give R1 as 3 ohms.